So, on our journey on this physics curriculum, we move on to moment of a force. When we talk about moment of a force, what does it mean? Moment of a force is basically explained as turning effect produced by a force. Moment of a force is basically explained as turning effect produced by a force. If I say that moment of a force is the turning effect produced by a force, have I defined moment or I just stated the effect of moment? What I did was to state the effect of moment. So we said that moment of a force is basically the turning effect, turning effect produced by a force. Question: Does this define moment or it takes the effect of moment? It just takes the effect of moment. That will take us to the next thing. Now, having said that moment is the turning effect produced by a force, before a force can cause an object to turn, the object must be pivoted or hinged at a point. So I should write that one down. Before a force can cause a body to turn, the body or the object can cause, let me use the word, before a force can cause an object to turn, the object must be pivoted or hinged at a point. What that simply means is that, having said that moment of a force is the turning effect produced by a force, before a force can cause an object to turn, the object must be pivoted or the object must be hinged at that point. The object must be pivoted or the object must be hinged at that point. So, for example, if I have this particular bar hinged on a pivot here, more practically, is hinged on a pivot here. Which of these? So, because this object is hinged at this point, if I apply a force, that force can cause the object to turn. So, which of these forces, force F1 applied like this, or force F2 applied like this, will cause this object to turn about this pivot? Which of the two forces, F1 or F2, will cause this body to turn about this pivot? Force F1 will not cause the body to turn. So the one that will cause the body to turn is force F2, which is like this. And force F2 is acting perpendicularly to the distance from the pivot. So the first thing we need to know, the next thing we need to know about moment is that it is the line of action of the force acting perpendicularly to the distance from the pivot that will produce a turning effect. So it is the line of action of the force acting perpendicularly to the distance from the pivot that produces a moment. Another word for moment is torque. So it is the line of action of the force acting perpendicularly to the distance from the pivot that produces moment or torque. So, having gotten the fundamentals, what are the fundamentals there? The first fundamental there is that moment is basically known as the turning effect produced by a force. Another fundamental there is that before a force can produce a turning effect on an object, the object must be pivoted or hinged at a point. Then, from common sense, logic simply tells us that if I apply these two forces, F1 or F2, the one that will cause the body to turn about the pivot is F2. And F2 is acting perpendicularly to the distance from the pivot. So it is basically the force, it is the line of action of the force acting perpendicularly to the distance from the pivot that will produce a turning effect. Or I can as well say that it is the force whose line of action is acting perpendicularly to the distance from the pivot that will produce a turning effect about the pivot. So having gotten the fundamentals, we can now define moment. So moment is defined as the product of the force and its perpendicular distance from the pivot. So moment is defined as the product of the force and its perpendicular distance from pivot. So moment, which is also referred to as torque, is the product of the force and the perpendicular distance of that force from the pivot. So that is what defines moment. Is the product of the force and the perpendicular distance of the force from the pivot. Let's take some few examples. Let's take some few questions. Calculate the moment of the force about the pivot in the figure shown below. In the figures shown below. Number one, have a 4 Newton's force at a distance of 2 meters from this pivot. Have an 8 Newton's force acting at 30 degrees. At a distance of 6 meters from this pivot. Then number 3. So calculate the moments of the forces shown below. Calculate the moment of the forces about the pivot in the figure shown below. The first one is this. You have a 4 Newton's force acting perpendicular at a distance of 2 meters from the pivot. So the moment of that force, which is the torque, is the product of the force and the perpendicular distance from the pivot. So this becomes product of the force and perpendicular distance from the pivot. So this will give you 4 newtons multiplied by 2 meters. This is what? 8 Newton meters. This one, calculate the moment of this 8 newtons force from the pivot. This 8 newtons force has 2 components. We have the vertical component, which we have taught you how to, we have explained before, how to find vertical component of this force. That will be 8 sine 30. As well as the horizontal component, which is 8 cos 30. Which of these 2 forces will cause the object to turn about the pivot? Is it the vertical component or the horizontal component? The horizontal component cannot produce a turning effect. The one that produces a turning effect is the vertical component, which is basically 4 newtons. So the moment is the product of the force and the perpendicular distance about this pivot. So it is the force whose line of action is acting perpendicularly to the distance from the pivot that will produce a turning effect here. And that is the 4 newtons force. So the torque will now be the product of the 4 newtons force or if you want me to write it, a product of the force and the perpendicular distance. So the force producing the moment here will be the 4 Newton's force. The perpendicular distance is 6 meters. So this is 24 Newton's meters. Then this other question, we have a 6 Newton's force pulling this object in this direction. What is the moment? Moment is the product of the force and the perpendicular distance from the pivot. So the perpendicular distance of this force from this pivot is not this distance. It is this distance. So I can find this distance using a right angle triangle. So that distance perpendicular to the line of action of the force. So I can say that sine 30 is equal to the distance acting perpendicularly to the force from the pivot over 10 meters. So this substitute y, that is the force acting perpendicularly to the distance from the pivot, will be equal to 10 times sine 30. And that will give you what? 5 meters. Because sine 30 is half. So the moment of the force will now be product of this force multiplied by the perpendicular distance from the pivot. This will be 6 newtons multiplied by perpendicular distance from the pivot, which is what? 5 meters. This will give you what? 30 newtons meters. If we don't want to do it like that, you can also find the force acting perpendicularly to this. So we can easily do that by looking at this force here. So you can see that this force, this 60, is also, this force will be 6 sine 30. So I can now say that the moment we product of 6 sine 30 multiplied by 10 meters, 6 sine 30 is 3. 10 meters, so I have 6 sine 30, which is 3 meters multiplied by perpendicular distance from the pivot. That will be 3 newtons times 10 meters, which will give you 30 newtons meters. So it's either I make the force perpendicular to the distance from the pivot, or I find the perpendicular distance of that force from the pivot. Both of them will give the same thing. So the moment here, otherwise, or for this 3, it will be the product of this force and the perpendicular distance from the pivot. So that will be 6 sine 30 multiplied by 10 meters. That will give you 3 times 10. And that will give you 30 newtons meters. Okay? Very quickly, we move to the next one. The next one is couple. When we talk about couple, what does couple mean? The word couple basically means two. But this time around, we're talking about a couple of force. And when we talk about couple of force, what does it mean? You have two forces. So a couple consists of two equal, opposite, and parallel forces whose line of action do not coincide. What do you mean by saying that the line of action of the two forces do not coincide? It means that the two forces are not acting at the same point. So couple consists of two equal, opposite, and parallel forces whose line of action do not coincide. And a couple will produce a turning effect, which is called moment of that couple. So a couple produces a turning effect. A couple produces a torque, which is moment. So for example, if I have a case like this, I have the following system. This force F, this force 2F, this force F, this force F, this force F, this force F, this is force 2F, this is force 2F. Which of these, A, B, C, or D, is a couple? A, the two forces are opposite, parallel, but they are not equal, so it's not a couple. Because a couple consists of two equal, opposite, and parallel forces whose line of action do not coincide, meaning that the two forces are not acting at the same point. B, you have two equal forces. The two forces are parallel, but the two forces are not opposite, so this is not also a couple. C has two equal forces, opposite and parallel to each other, so this is a couple. D, you have two equal forces, parallel but not opposite, so this is not a couple. So like this case now, I have a force acting there, I have another force acting there, so the couple applied on this object will cause the object to rotate. So a couple produces a turning effect, which is moment. So the moment of a couple, which is torque of a couple, is basically the product of one of the two forces. Product of one of the two forces and the perpendicular distance between the two forces. So that is the moment of a couple. Product of one of the forces and the perpendicular distance between the two forces. Okay? So question. Calculate the torque of the couple shown below. If I have something like this, I have 5 Newton's force, I also have 5 Newton's force, this 3 meters. Here, I have 6 Newton's force, I also have 6 Newton's force. This is 8 meters. This is inclined at 30 degrees. This is also inclined at 30 degrees. You want to calculate the torque of the couple shown below. The torque is the product of one of the forces and the perpendicular distance between the two forces. So the force here is 5 newtons times the perpendicular distance between the two forces. So this will give you 15 newtons meters. Here also the torque is product of one of the two forces and the perpendicular distance between the two forces. So we need to find the perpendicular distance between the two forces. So that means we should find the force acting perpendicularly. So if you find that force, let's call it Fy here. Let's call it Fy. Fy here will be 6 sine 30. So Fy is 6 sine 30, which is equal to 3 newtons. So Fy here is also 3 newtons. So the torque will be product of one of the forces, which is 3 newtons, and the perpendicular distance between the two forces, that is what? 8 meters. So the torque is 24 newtons meters. If I don't want to do it this way, I can find the perpendicular distance between the two forces. Instead of finding the perpendicular forces, I can just find the perpendicular distance between the two forces, which is this or this. So this is the perpendicular distance between these two forces. Okay? Perpendicular distance between the two forces. So I can find this distance. Let's say that this distance is x, but this distance is 8 meters. So I can say that sine 30, so, or, follow me, or sine 30 is equal to x over 10. So x becomes 10 times sine 30. X times 10 times 30 becomes 5 meters. So this distance here is 5 meters. So the torque will now be product of one of the forces, 6 newtons, multiplied by the perpendicular distance between the two forces, which is 5 meters. And that will give you, sorry, I said this is actually 8. Let me not rush this because this is a very important concept. So what I'm going to do is to explain the alternate method. Yeah. So what we are saying is this: you have this. This is 6 newtons. This is also 6 newtons. This 30 degrees, 30 degrees. This is 8 meters. So the couple is also product of one of these forces and the perpendicular distance between the two forces, which is this distance. So let's say this distance x. How do I find this x? I can say that sine 30 is equal to opposite x over the hypotenuse. That's the perpendicular distance there. Sine 30 is equal to x over the hypotenuse 8. So x becomes 8 times sine 30, which is equal to 4 meters. So the torque becomes product of one of the forces, 6 newtons, multiplied by the perpendicular distance between the two forces, which is what? 4 meters. So this will give you 24 Newton meters. Okay? So you can as well do it like that. So it's either you find the perpendicular forces, which is actually 6 sine 30 here. Perpendicular forces, and that is actually 3 newtons. Then the moment becomes product of one of the forces and the perpendicular distance between the two forces. That becomes 3 newtons times 8 meters, which is 24 Newton meters.